We're going to take a look at piecewise functions. So you've been working on these, and we're going to go ahead and graph this one here. So remember to really distinctly think about where the boundaries are that you're trying to set for your graph. So this boundary is at 0, so in my head I'm thinking about at 0 is where I want to kind of separate. And less than 0, I want to graph y equals 2x plus 1. And when x is greater than or equal to 0, I want to graph y equals negative 1 half x plus 2. Okay. So I'm going to start with y equals 2x plus 1. If I put some dots on the graph, I'd start with the y-intercept and go up 2 over 1, up 2 over 1. Right now, I'm making the points that would form the entire line. But remember, because it's part of a piecewise function, I want to cut it right here where x is equal to 0, and I only want it to be on this side of the boundary. So I can see this point right here is on the boundary, and because in the equation it says it should just be less than 0, that boundary point should actually be an open circle. And these points on this side aren't going to be valid because our graph can't be there. So I'm going to go ahead and graph just this portion of the line. Then y equals negative 1 half x plus 2. I would start with the y-intercept of 2 and go down 1 over 2, down 1 over 2, down 1 over 2, or up 1 over the other direction too. But again, remember, we have our boundary and we only want to graph it on the right side. So I would go ahead and erase any points on the left side of the boundary point I see here. Because it can be equal to, I'm going to keep that as a closed point and go ahead and graph the other portion of our line. And that would be our piecewise function graph for this equation.